Hello, mathletes. We are going to be covering greatest common factor, but this time we're going to be using prime factorization to find our GCF. And here we go. So, prime numbers are numbers that have factors that are 1 in themselves. There are no other numbers that will divide evenly into these numbers other than 1 in themselves. So, for instance, we see some prime numbers here. You take 5. 1 will divide evenly into 5, and 5 will divide evenly into 5 with no remainder, fractional parts, or decimals. So that's it. And all of these numbers are numbers that have that same situation where only 2 factors, and one will be the number 1 and one will be the number itself. So that's what a prime number is, and we're going to be using prime numbers to factor these numbers and find out what is the largest or greatest number that will fit into both of these numbers, divide into both of these numbers evenly. So we are going to begin, and what we want to do with these, of course, is try to figure out where we can begin by using one prime number. So any even number, we can begin with a 2. A 2 is going to divide evenly into any even number. So 2, and that would leave me another factor of 6. So 2 times 6 becomes 12. I'm going to circle the 2 because it's a prime number, and that's what I'm looking for. I'm looking for the prime numbers. 6, of course, can be the product of 2 times 3. So I'm going to circle the 2 and the 3 because they are both prime numbers. And now I have my prime factorization of 12, and that would be equal to, and we want to do these in number order, 2, and I'm going to strike them as I use them so I don't make any mistakes, times 2 times 3. We only have a few factors here, but sometimes there are many, so we want to make sure we're keeping track of what we use and what's not used yet. So we can see, we can check our work here. 2 times 2 is 4, 2 times 2 is 4, times 3 is 12, and I'm good. So 18, we can do the same process. So I can start with a 2 and a 9. There are other ways I could have divided up that number up to begin with, but 2 times 9 will get me 18. I'm going to circle that 2 because that's a prime number. And of course, 9 is a product of 3 times 3. I'm going to circle these numbers. So 18 is a result of 2 times 3 times 3 as the prime factors. So we can check our work again. 2 times 3 is 6, times 3 again is 18. I'm good on both of those. So now my job is going to be to find all the common prime factors. So I have a 2 in common here, and I have a 3 in common here. That's it. I don't have another 2 to match with this one, and I don't have another 3 here to match with this one. These are my only 2 common factors, which means that the greatest common factor of 12 and 18 is going to be the product of these, which is 2 times 3, or 6. So again, we find all common factors to both lists, and then we multiply them together to get our greatest common factor. So the largest number that will divide evenly into a 12 and an 18 is the number 6. So a lot of times we work through these with, these are called factor trees. We just keep dividing the number into 2 factors, 2 factors, 2 factors until we get all prime factors. There's another way we can do this, and we can try it the other way as well. So I'm going to start over here, and we will give it a go with the other process. So this is the other way that it's done sometimes, and this is fine as well. You can just give yourself a division house and put your numbers within it, and then just start dividing by the smallest prime you can, and in this case it's a 2. So I would say 2 would divide into 12, 6, and then I continue that process. And then again, I'm going to use a 2 again. 2 goes into 6 3 times, and now I have all primes. So 12 is 2 times 2 times 3. And then here I'm going to start with a 2 again because this is an even number. 2 goes into 18. And then 3 goes into 9 3 times. And 18 is 2 times 3 times 3. And again, you see we have the same thing here. We have the 2's in common. We have the 3's in common. And then we multiply those together. So the GCF of 12 and 18 would be 2 times 3 or 6. So this is just another process. Both of them are absolutely fine. We can work with either one. I tend to do the factor tree. But if you like this better, this is something you can use. All right, let's look at these a little bit larger numbers here. So 48. So we can start anywhere, but it's even. We can take out a 2, and that leaves us 24. 2 times 24 is 48. I'm going to circle that. That's a prime. I'm going to continue to use 2. 2 times 12 is 24. I'll continue to use a 2 because these are all even. 2 times 6 is 12. And 2 times 3 is 6. So 48 gives us, is equal to 2 times 2. Again, striking these out, making sure I'm not missing anything. There's a lot of 2's here. Times 3. And I have all my factors there. 72. Again, it's an even number. I am going to take out a 2. And that leaves me 36. And then 36, I know, is 2 times 18. You could have done 6 times 6. That would have been fine too. 18 is 2 times 9. And 9 is 3 times 3. So for 72, we have 1, 2, 3 2's being multiplied together. And we have 1, 2, 3's being multiplied together. And again, we can multiply these all together on our calculator in our head and make sure that our number is correct. And then we're going to look for those common factors. I have a 2 in common. I have another 2 in common. I have one more here. And here I just have 1, 3. I don't have a match for this 2. I don't have a match for this 3. So that means our greatest common factor for 48 and 72 is going to be the product of 2 times 2 times 2 times 3. 2 times 2 is 4. Times 2 is 8. Times 3 is 24. So 24 is the largest factor, common factor, of 48 and 72. It's the largest number I can divide evenly into both of these. All right. So now we are going to go to check and correct. This is your opportunity to try the work on your own and to be able to check in and correct it with the video. So you can stop the video now and do these 2 problems and then come back and check and correct your work if necessary. All right, we'll see you in a moment. Welcome back. Hopefully you have your factoring finished here and have arrived at a greatest common factor. We're going to begin now with 36. So I'm going to just do it a little differently. I was using my primes right off the bat, but we can also do 6 times 6 for 36, and then we can split those into 2 factors here, which now I would have all primes. So 36 would be equal to 2 times 2. I'm going to keep them in number order just to make sure that my work is organized. And that's our factor list for 36. And then we have 54. I'm going to use a 2 here and 27 here. That's prime. I know 27 is in your times tables. It's 3 times 9. So I can use that. And then 9, of course, is 3 times 3. So 54 is a result of 2 times 3 times 3 times 3. And now we're going to look for those common factors, which will give us our greatest number when we multiply them together. So we do have a 2 in common here. This 2 does not have anything in common, but I have a 3 in common here, and I have another 3 in common. So this has no pair, this has no pair, but we do have the greatest common factor for these two numbers is going to be the product of 2 times 3 times 3, and 2 times 3 is 6, times 3 again is 18, and that would be our greatest common factor. All right, let's look at the other one. Erase that, give us some room here. And we have two numbers here. Actually, you know what? Let's do it the other way, just in case that was of interest to you. So let's try it this way. And again, you can do these either way. It's entirely up to you, whatever is easier for you or makes more sense to you. So I'm going to use a 2, and 2 goes into 30 15 times. I can use a 3 here, and that's a 5. So my 30 is the result of 2 times 3 times 5, 42. Again, I can use a 2 right off the bat here. And then I can use a 3, and 3 goes into 21 7 times. So 42 is the result of 2 times 3 times 7. And let's just check this work to make sure. 5 times 3 is 15, double that is 30. 7 times 3 is 21, double that is 42. Looks good. All right, and let's see what we have in common here. It looks like we have a 2 in common. We have a 3 in common. There's no 5 in both. There's no 7 in both. So we have our answer then. So the greatest common factor of these two numbers, the largest number that will fit into both of them, divide in evenly, is going to be the product of 2 times 3, and that is 6. So 6 is the largest number that will fit into the two of these numbers evenly. All right, so that leaves us to our mathing it up on our own. You have two sets of numbers here. You're going to do prime factorization for both of these, and then take all common prime factors, multiply them together, and that will give you your greatest common factor for this set of numbers and then for this set of numbers. All right, well, thanks so much for joining today and advocating for yourself. Great time to do this extra work is when it's fresh in your mind. Just give your brain some more practice with it. And have a great day.